Good afternoon, class. This is practice test number 5 for algebra, module 5, chapter 11. Chapter 11 is conic sections. Given the points -4, 2, and 2, -6, we want to find the distance and the midpoint. So first, let me remind you of both formulas. When we want to calculate the distance, Pythagorean theorem proves that distance is the square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. The simple reason is because if you square this side and square this side, add them up, it's the same as squaring this side. And so we are going to simply plug in, as we do that, 2 minus -4 makes it +4, so this is 6 squared. -6 minus 2 is -8 quantity squared. This becomes 36. 64 square root of 100, and the answer is 10. As far as the midpoint goes, simply put, if you look at this, we add up the x coordinates and the y coordinates. And for that, we are going to add up -4 and 2 divided by 2, +2 and -6 divided by 2 to find the midpoint having coordinates -1, -2. Find an equation of the circle with its center at 1, -2 and radius 2. Graph the circle. So first and foremost, this is how we get to conic sections. A conic section has a definition: a curve in a plane that is the result of intersecting the plane with a cone. So depending upon how it cuts it, it creates a parabola, circle, ellipse, and hyperbola. Types of conic sections include parabolas, circles, ellipses, and hyperbolas. Graph of ax squared plus by squared plus cxy plus dx plus ey plus f equals 0, where a, b, c, d, e, and f are constant. These are the equations in general. So a circle is defined as the set of points in a plane that are the same distance, called the radius, from a fixed point, called the center. So if we happen to have the center at the origin or 0, 0, the standard form is x squared plus y squared equals r squared. If it's centered at some other location such as h, k, then it's x minus h quantity squared plus y minus k quantity squared equals r squared. And in addition to that, I'm going to remind you that the area is pi r squared and the circumference is 2 pi r. And we said in this case, we know the radius is 2. Center is located at 1 minus 2. So plug in x minus 1 quantity squared plus y minus -2, which makes it +2 quantity squared equals r, which is 2 squared, which makes it 4. So this is the equation. So here's the center located at 1, -2. And now we are going to go 2 units to the right and left, 2 units up and down. In other words, r units, whatever r is, and we get those 4 points. So if we go 2 units left and right, so that means if this is the x coordinate of the center 1, you are going to add the r, make it 3, and subtract it, make it 1 minus 2 equals -1. Those are the 2 pairs. Also, we're going to go up and down by r units. So up and down, so it's the y coordinate, go up. That means -2 plus 2 makes it 0. Go down, -2 minus 2 makes it -4. And there you have it. Put them all together, and you have a graph of a circle. Write the equation of a circle in standard form, identify the center and the radius, graph the circle. So we want to go from here to here. To do so, we use completing this square, which means we're going to put these two together, and the constant moves to the right. Now, what do we need to add here? Let me just remind you that this is B. You are going to, and this is B for this one. You're going to divide by 2. This becomes -2. You're going to square it, and therefore you add 4. If I add 4, I need 4 here too. So for this one, I need to add 4. For this one, 10 divided by 2 is 5, squared is 25, and I need to add 25. So that's what we are going to do. You end up with x minus 2 quantity squared plus y plus 5 quantity squared plus y plus 5 quantity squared equals r squared, or 36. That means the center is at 2, -5, and r is the square root of 36, which is 6. Now we can come up with the center, and 2, you go to the right and left by r units. You go up and down by r units. So to the left and right, you add 6 to number 2. Up and down, you add 6 and subtract it from -5. And now you put them all together and you have the graph. This is one fairly easy way of graphing. Given the function f of x equals 2x squared plus 4x plus 6, express it in standard form. Sometimes they call this the vertex form. I don't like to call it standard form, but I call it here because it's given. However, it's a vertex format. Sometimes they call this one standard form. And find the x-intercept, the y-intercept, the vertex, find the axis of symmetry, and graph the function. All right, so first and foremost, what is a parabola? Parabola is defined as the set of points in a plane that are the same distance from a fixed point called the focus, and from a fixed line called the directrix. So if you look at this, any point that you pick, for example here, the distance from here to this focus, focal point, and the distance from a directrix, these two must be identical. This distance obviously is the same as this one by this definition. I hope you realize that. And that's called focal distance. Sometimes they call it P, sometimes they call it A. And with that being the case, this is a distance of, notice this is 2A, so is this one, so it's 4A, 4 times the focal distance. It's called latus rectum as far as the terminology is concerned. Now, so to do this, I'm going to go by completing the square. Not that you have to, but I will discuss both methodologies, how to come up with the vertex. So for a case like this, you really don't go with completing the square unless they ask you. But I wanted you to be exposed to that, which means you're going to put these two together and you take a 2 out to. By the way, the general formula when it opens up, y equals a times x minus h quantity squared plus k, or ax squared plus bx plus c. And we also have it sideways. Let me also write this one for you. Let me write a couple of formulas. For this one, also you have y equals ax squared plus bx plus c. For this one, you have x equals a times y minus k squared plus h, or you have it in this case, ay squared plus by plus c, when it opens sideways. All right. So now again, b is 2, divided by 2 becomes 1, square it becomes 1. So here's what's happening. When we add 1 inside the parentheses, that means we are adding in essence 2 times 1. So plus 2. Add 2 to both sides, or it's just, since this is 2, also subtract it. Either way is fine. We like to keep it on the same side. That's why we are going to subtract. Please pay attention. We are adding 1 and then 2 times that. And so A is 2. Vertex is located at negative 1, 4. A is positive. It opens up. By the way, this is a quadratic with respect to x. That's why it opens up or down. A is positive 2, therefore it opens. So vertex at negative 1, 4. So we come up with the vertex. The x-intercept is none. The y-intercept is 0, 6. So this is the location of y-intercept. How do we know the x-intercept is none? I hope you realize that if you go back here and you calculate b squared minus 4ac, because if you set this equal to 0, if you set this one equal to 0, that's how you find x-intercept. And since b squared minus 4ac, and I leave it for you to prove that, is negative in this case, b is 4 squared minus 4 times 2 times 6. This is negative. There are no real solutions, and it's only real solutions that correspond to x-intercepts, no x-intercepts, therefore. And so axis of symmetry, x equals negative 1, the x coordinate of the vertex. And when we draw that, notice using the concept of axis of symmetry, by the way, in calculus, what we do draw it like this, meaning it can't cross that, okay, class? And we know it opens up because A is 2, right? Since it opens up, by axis of symmetry, this distance is 1. So if you go the same distance of 1 here, we will have the same height. That creates this pair, negative 2, 6, because of this. And we have that. If need be, you can draw more points. There is no need for that. That's your graph. Now, the thing I want to add quickly is that if you don't want to go through completing this square, everybody, you could use x equals minus b over 2a, which is minus 4, 2 times 2 equals negative 1. So you don't have to go through completing this square. If this is the x coordinate of your vertex, what is your y coordinate? Plug in negative 1 and evaluate it. That may be slightly easier. Write f of x equals x squared minus 6x plus 8 in the form of f of x equals a times x minus h quantity squared plus k. Then determine whether the graph opens up or down, find the vertex, axis of symmetry, and draw the graph, find the domain and range. And we are going to go again by completing the square. Needless to say, you don't have to do that. I can't emphasize this enough unless they ask you. So with that being the case, clearly A is 1 and it opens up. X-intercept y equals x squared minus 6x plus 8. So it's easier just to deal with that. We factoring, we end up with 2 and 4. So it's important to know the meaning of 2 and 4 is 2, 0, 4, 0. When you answer the question, you answer it according to what they ask you. X equals minus b over 2a. If I don't want to do the solution by completing the square, as I showed you in the previous page, let's see what happens. Bear in mind, a is 1, b is negative 6, and c is 8. So b is minus b over 2a gives you 3. Now, if you put it back in, 3 squared minus 6 times 3 plus 8 gives you negative 1. We have the pair as the vertex. and the x coordinate is 3. Therefore, the axis of symmetry is x equals 3. Make sure you write an equation, not just 3. X equals 3. And it's a good practice to write the summary of what you found here. So take a look. We have the y-intercept. We have one of the x-intercepts here, another one here, and here's the vertex. And one more pair. Again, I will discuss that on the graph for you, starting with the graph and the axis of symmetry. Here's how the graph looks like. Notice we had the y-intercept located at 0, 8, and it's very easy to look at the original function when x is 0, it's 8. In other words, the constant 8, 0, 8. So you have 0, 8, and all you have to do, look at the vertex, the x coordinate is 3, so this distance is 3. So if I go same distance 3, I must have another point having the same y coordinate, and that results in 6, 8. This is really the method you should do. However, if they ask you for completing this square, I want to show you a slightly different method because some students may have a difficult time doing that. First of all, the domain is always all real numbers in the case of a parabola that opens up or down. But what about the range? It depends on the location of a vertex. When it opens up from the y coordinate, which happened to be -1 for the vertex to infinity, if it opens down from -infinity to the y coordinate of the vertex. So we want to put these two together. We can move the 8 and then bring it back. This is another, because some students I've noticed they are more comfortable with that. That's fine. Okay, b is -6 divided by 2, -3. Square it, 9. Add 9 to both sides. Left side is y plus 1, and right side is x minus 3 quantity squared. All you have to do, move the 1, and it makes a -1 on the other side. So if you look at this one, also gives you the same vertex of 3, 1. Again, if you are asked to use a specific methodology, you do that, otherwise you don't have to. Graph the ellipse, x squared over 25 plus y squared over 16 equals 1. So what's an ellipse? An ellipse is a set of points in a plane, the sum of whose distances from two fixed points is a constant. The two fixed points are called the foci. Each is a focus of the ellipse. F1 and F2 represent the two foci of an ellipse, where PF1 plus PF2 equals to A. What do we mean by that? If you take a look at this one, this is elongated along the x-axis, and it doesn't have to be. In this case, A, 0, negative A, 0 are the vertices. 0, B, 0, negative B are called the co-vertex or co-vertices. F1, F2, by definition, if you pick any point, let me pick another point so you can see that if you pick any point, let's call this now P sub 2. And connected to the two foci, PF1 plus PF2 is fixed. And that happened to be 2A. And the proof that it is 2A, if you pick this point, let's call this point A. You can see that AF1 plus AF2 is fixed, and AF2 can be replaced with, let's call this B, let's call it A1 and A2, because this is 0B, and I don't want to mix them up. And so A1 F2 is the same as A2 F1, and that's a proof. You can look at it later on. In the meantime, the equation centered at 0, 0 is this one, centered at HK. So centered at 0, 0, x squared over a squared plus y squared over b squared equals 1. Centered at a different location, such as h and k, x minus h quantity squared over a squared plus y minus k quantity squared over b squared equals 1. Now, if you recall, a circle has an area of a equals pi r squared. A circle is a special case of an ellipse where a and b are equal. If you set equal to b, if this distance is equal to this distance, becomes a circle. which gives you the area of A equals pi r squared. So this one is pi AB. And A and B and C follow Pythagorean theorem. The largest one is the hypotenuse. In this case, because it's elongated along the x-axis A, this distance is A. From here to here is A. This distance is A. This distance is B. Because it's elongated along the x-axis, A is larger than B. But if it's elongated along the y-axis, it may be the other way around. So you want to follow that accordingly. So with that being the case, it is centered at 0, 0 when you compare it to this one. A square root of 25 is 5. B square root of 16 is 4. And so let's write the center at 0, 0. And the vertices, because A is a 5, 5, 0, negative 5, 0, because B is 4, 0, 4, and 0, negative 4. Those are the co-vertices. And we can graph those, and it looks like this. As you can see, it's elongated along the x-axis. Now we have a different one. We want to identify the coordinates of the center, the vertices, the co-vertices, and foci. We want to graph it. So again, as you can see, compare, and you notice it looks like that. Therefore, the center is located at -5, +7. A is square root of 4, which is 2. B is the square root of 9, which is 3. And clearly, B is larger than A. Therefore, it's elongated along the y-axis. So here's the center. And again, B is 3 going up and down by 3 units. So B units up and down. B happen to be 3. Anything that gives us, those are the two pairs. Going back to the center, A units to the left and right, which happen to be 2 units. Now, we can also calculate the foci using this formula. It's important to understand that because it's elongated this way, clearly B is larger than that. So now the formula changes. B squared plus C squared equals A squared, or A squared plus C squared equals B squared. You use the one that makes sense. Please understand, A and B could change. With that being the case, we go with A squared plus C squared equals B squared, which means well, actually we have this square. A squared is 4, so let's write it. This is 4. This is missing. This is 9. C squared becomes 5, and C is square root of 5, which means you go back to the center, and the foci is also located along where it's elongated, okay, the vertices. So in this line. So because of that, if it was about this line, you would go to the right and left this much, but it's elongated along the y-axis. You go back to center, up and down by this much. So if we go down, we subtract it. If we go up, we add it. And again, an approximation for the sake of graphing. This is precise, it's an approximation, put them all together. Here's the graph, and we're done with that. Given the equation of asymptotes and graph of the hyperbolas, we want to give the equation of the asymptotes and graph the hyperbolas. Here's the two hyperbolas we want to graph. So number one, let's discuss the hyperbolas. A hyperbola is a set of points in a plane. The difference of whose distances from two fixed points called the foci is a constant. In other words, PF1 minus PF2 equals 2A. So if we look at this, if you pick P, this is F2. So PF1 minus PF2 is fixed. That is the definition. And in a case like this, x squared over a squared minus y squared over b squared equals 1, where x squared has a coefficient which is positive, it opens sideways, and it has vertices at a0 and negative a0. If it's in this format where y squared has a positive coefficient, and by the way, I like to keep the b, or in this case b squared, under y squared. You'll see in a moment why. In this case, then we have it that opens up or down with the vertices at 0b. In other words, for this case, the graph looks like this with the same asymptotes. So this is the reason I like to keep it this way. Take a look at the formula for the asymptotes, plus minus b over a times x. If we don't change that, this will always be b over a plus minus x. Also, the focal distance is always larger than a and b, both of them. Therefore, a squared plus b squared equals c squared, which follows a Pythagorean theorem that we had it in elliptical form. It works here also, and c is always larger than both. Therefore, we stick with that. So let's go to this one. The center is at 0, 0, the same as here. And in both cases, a, what's under x squared, take a root, becomes 4. B, what's under y squared, 25, take a root, is 5. So in both cases, this works. The center, A and B. Now, for this guy, because the x squared has a positive coefficient, then a 0, that means 4, 0, and negative 4, 0 would be the vertices. What about the asymptotes? The asymptotes plus minus b over a, y equals plus minus 5 over 4x. It's the same for both of them. And so we have this. By the way, before we continue, this is a rectangle that is called a fundamental rectangle. The purpose of that is to help us draw the two asymptotes. So if you connect them in this manner, so this is a comma 0, this is negative a comma 0, this is 0 b, this is 0 negative. If you connect them, then their diagonals would be the lines, or just go with that. The purpose is to help you for the graph of asymptotes. Now, here's the graph for the top one. Let's add the asymptotes, and we're done with part A. Now, for part B, everything is the same with the exception of the vertices. For part B, the vertices have a different location. Now, because y squared has a coefficient which is positive, see, this one has a negative. Therefore, look at b equals 5. So 0, 5, and 0, negative 5 would be the vertices. And the graph looks like that. And let's add the asymptotes. So the reason I put the two questions next to each other, because I want you to see that they use the same center, the same A, the same B, the same asymptotes. Both of them have the same asymptotes. Identify the graph of each equation. In general, if you know you have a conic section, and you do have it if it happened to be, for example, that x and y are both having a degree 2, okay? And if it's on the same side, notice they have identical coefficients. That becomes a circle, okay? This one, they have coefficients that are both positive. That becomes an ellipse. This one, if you bring it to the left side, they have opposite signs. That becomes a hyperbola. Again, if somebody says prove it, you have to put it in standard form. But if somebody says, okay, can you quickly tell us what type of a graph? This is how you do that. A quick recap. Identical coefficients. Coefficients have the same sign. When you bring them to the same side, they have opposite signs. Now, if one of them is of degree 1 and one of them is of degree 2, that means either x or y is of degree 2, only one of them, then it's a parabola. And if you look at this one, when it's of degree 2, when x is of degree 2, it opens up or down. Since a is negative, it opens down. Since a is positive 1, opens up. Since the degree is 2 for the y, so it opens sideways, and because a is 1, opens to the right. So down because of x squared and negative 2. Up because of x squared and a equals 1. Right because of y squared and a equals 1. By 1, we mean really positive. We want to solve this system, and we follow what we have learned about basic system. This is a nonlinear system of equations. All you have to do in this case, y is x squared plus 2, replace this. 2x squared, subtract the 2 equals 2, and x squared becomes 1. X becomes plus minus 1. Now you have to go back to, let's say, this one. Y is, now you have to put 1 to see what happens, negative 1. Both of them become the same because when you square them, it doesn't matter. And you find the y to be 3. Now, it's important to know what this means. We got the x, we got the y. What does it mean? The following two pairs, negative 1 with 3 and positive 1 with 3. And you must check with which equation, the one we haven't used yet. Check with equation number 1. We haven't used it yet. We want to solve this system. Again, remember substitution or addition, elimination, whatever that works. There's really not much you have to do. Just add them up. These two cancel each other. So 3x squared and x squared, that gives us 4x squared. 12 and 16 gives us 28. Divide by 4, x squared is 7, so x is plus minus square root of 7. So pick any of them. For example, if you use this one, again, since x is squared, doesn't matter, positive or negative, gives you the same thing. Square that. Plus y squared must be 16. As you can see, we have 7 plus y squared. Subtract it from 16, you get 9, and y becomes plus minus 3. And again, what does it mean when you have this one and this one? It means the following 4 pairs. And that is extremely important that you notice that. And also check. How do you check? Remember, we use, this is the equation we use, right? The first equation is not used. So check it. At least check 1 or 2 of them, if not all, just to be on the safe side. We want to graph this one. And as I mentioned, when y has degree 2, then it opens sideways to the right or left. It depends. I hope you realize a is negative 1, and therefore it opens to the left. However, let's go through the process. If we want to graph this, the first thing is to find the vertex. So this same thing, minus b over 2a, that was the x coordinate before. Now it's the y coordinate. In other words, it was h and now it's k. So minus b over 2a. So minus a, 2 times negative 1 makes it 4. So that is the y coordinate of your vertex. Put it in. Minus 4 squared plus 8 times 4 minus 7 will result in 9. I hope you realize that 4 squared is 16, and the negative makes it negative because negative is not being raised to the second power, and we need to add 8 times 4, which is 32, subtract 7. So that's how we arrive at 9. So the vertex is located at 9, 4. A is -1, and it opens left. The reason it opens left, A is negative and Y has degree 2. So we have this location, and now Y-intercept, set X equal to 0, which means set this one equal to 0 and solve. So we want to solve this. In order to solve this, let's take it to the other side because we like this negative to become positive. And now we can factor, we need two numbers, the product is 7, the sum is -8, we get -1 and -7. This gives us 1, this gives us 7. What does it mean? 1 means 0, 1, 7 means 0, 7, and those are the two pairs. And I hope you realize that if you set Y equal to 0, everything goes to 0 except -7, and that's the location for the X-intercept. And here's the summary of everything. And now we graph it and we are done.